Welcome back. Okay, so we were just talking about how we want to update our script to basically constantly ask the lighting controller what its current level is. Because sometimes it might not report that on its own when someone just presses the button on the wall, or if it changes via something else in our script, some other function in another script that we may have chosen to update the lights. In order to do that, we kind of got to bug it. We just got to say, hey, lighting controller, what you doing? What you doing? Are you on? Are you still on? What's your level? What's your level? What are you at? Tell me. We got to do that constantly. And that may seem like it's like a lot to do, where you're like, why would I really want to flood my network traffic with someone constantly asking across the system what it is? Don't worry, this is very, very, very low level traffic. You don't want to poll it like every millisecond, but we're going to poll it at a reasonable amount of time so that we're always up to date. And your IT department will be fine with it, I promise. So in order to do this, we're going to create what's called a poll. The poll is a regular occurrence of us asking that device what its state is. In order to do that, we're going to be using a new timer, different than the timer we did previously. So here's what named timers look like in the block controller. There's 4 blocks that are associated with creating a named timer. The first one is the create timer block. This is where you give a name to the timer, because you probably have potentially multiple timers in your script. You want to be able to choose which one you're doing. You have the very familiar crocodile mouth. That's our event handler for the timer. That's what happens when the timer is finished. It's called on timer tick. Personally, I don't like that nomenclature, because when I think of a timer, I think of something that goes tick, 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 ding. And to me, I would want this block to say on timer ding, because it's what happens when it completes. And to me, a tick is like a step along the way to a ding. But yeah, just get that out of your head. In this case, when the timer completes, after the time has elapsed, this is what will happen when the timer, has fulfilled itself. Other things we can do. We can start the timer. Obviously, it's not going to be running all the time. You can choose when it starts, and you can choose its tick interval. Again, in my mind, I want that to be ding interval. But basically, how long will the timer be? And that is input via a number, and that is always represented in seconds. So the number of seconds it takes for the timer to elapse, before or after which it will then execute its event handler. And then we also have timer stop. So if you don't want the thing to do the thing, you can stop it before it does the thing. That's very different than our previous timer, where we just said, hey, after X number of seconds, do something. That could not be stopped. This timer is much more flexible. We can start it, we can stop it, we can choose what it does. These are the blocks we're going to use to create our poll for our lighting controller. Okay, so if you go to the timers category, first let's create a timer. Drag that create timer out. You can name it whatever you want. I'm going to call mine Joey. My timer's called Joey because it's Joey Tribbiani, and it's saying, hey, how you doing? Hey, how you doing? How you doing? Over and over and over again, just asking what this device is doing.
Mine says, what's up, Doc?
That's pretty good too. So then let's create an event handler for our timer. On timer Joey tick, what's it gonna do? Well, we're just asking for its information. We're not changing its information. So far in this script, what have we done to send to the device? We did connection dev lights write. We used that to send information, and we wrote a string that set the LVL at the level that we wanted to send it. We don't want to do that. We don't want to change the level. We just want to ask what its current level is. And in our really good Lighting Designers API, it tells us what command we need to send that. If you look at it, it says to get level, we want to send the string GETLVL. So once again, you'll be looking in your lighting controller's manual or its website. It'll list all the commands it can receive in some place, and hopefully one of them is something like that, which is just a status get. So we want to send get LVL. So we'll use this same block down here in our lighting tick. So go to your connections, dev lights, write a string, and the string that we're going to write is GETLVL. Is that correct, Jeff?
Not quite,
Not quite. Why not?
because you need the talking stick. You need the end
talking
of line.
stick. Yep, you need to let it know that you're done. So GETLVL \R. Easiest way to get things like this wrong is to forget to tell the device that you're done talking. And then you're just sitting there and it's wondering why you're still there. But you're like, I'm done. Well, it's your turn. Okay, and for argument's sake, let's debug what we just did. So grab yourself a system print. And let's just throw in a real quick string that says, hey, how you doing? Or whatever it is you want to say, just to report that you did indeed issue a poll. All right, now that timer exists, but it isn't running yet. It simply does exist. We need to use that start block in order for this to start. So, when do we want to start it? When do we want to stop it? Do we want it to always run? If you just grab your timer and say start timer in the middle of your script, it will start when the script starts. Sure. Do you want it to be running the moment the Q-SYS boots up? Before the lighting controller is even there? Before it's booted up? That seems like it's a problem. What do you think, Jeff?
There are a couple different ways to think about how to do this. And I agree with you. I think that maybe starting in the main line of the code might not be the best place, but it also depends on what logic you want to put into the event handler.
Well, sure. In my case, I only want to ask if it's okay if it's there. That's going to be my barometer. If I'm connected to the lighting controller, then I want to talk to it, right? If I'm not, then I'm not. Well, if we go back to our connections and we look at our possible blocks for dev lights, you see any blocks that could be useful to us?
I do.
Which one?
Well, there is an event handler that tells me whether it is connected or not.
Well, I could use an event handler for when it connects to start. I could use it for when it disconnects to end it, but I want to do something a little bit different. I'm going to grab this is connected block, and I'm going to have it check every time it's about to poll whether or not it's connected, right? I am going to start this script at the top of the design, and every, let's say, 1 second when I want it to poll, before it sends the message, I'm going to have it stop and say, wait, is it connected or not? Because if it is connected, then I'll send the poll. If it's not connected, then I'm not going to send the poll. So I'll give myself a little flow control. And all of this is only going to happen if the dev lights is connected, right? That way, before it sends a message, it just double checks and says, if you are there, then I'm going to ask you. And if you're not there, I'm not going to ask you. And the reason I'm doing it here is because there's other things that I may want to do when it is connected or disconnected, and I can do the same thing here. For instance, on this UCI, I've got all these controls. If the device is not connected for whatever reason, if the lighting controller is broken, or if the connection between Q-SYS and that lighting controller has been severed in some capacity, I don't want someone at the UCI hitting these buttons wondering, why isn't it changing the lights? If those buttons are visible and active, then they're going to assume that they should work. So I want to also disable these buttons if it's not connected. So every second, when I double check if the connection exists, you know what I'm going to do? I'm going to disable those buttons if it's not connected. So I'm going to give myself an else. If the device is not connected, then I'm going to go to my controls and I'm going to say, hey, let's set the is disabled of all preset buttons to true. And let's set the is disabled of the lighting fader to true. So that if it's not there, those buttons gray out and they know that they're not going to work on the UCI. On the flip side, let's make sure to reset them. So if the device is connected, then we want to make these abled again, right? So I'll put the is disabled to false and set the is disabled to false up here as well. So now every second, what's going to happen? It's going to check to see if it's connected. If it is connected, then it keeps those controls visible, and then it asks how it's doing. If it's not connected, it's going to disable them. And this script just keeps on running under the hood. We don't need to worry about it. And it also means that we don't need to really worry about starting this particular script in a good state, because as soon as the core boots up, this timer starts running and it will automatically check itself to see, hey, is it connected or not? If it's not, I'm going to keep it disabled. Once the lighting controller is booted up, then we're going to turn those buttons on again. That is something that I like. It's all built into the event handler of the pole, and let's make sure it works. So, look down in your debug window every second. Hey, how you doing? Hey, how you doing? Hey, how you doing? If I go to my emulator and I turn the lights off, within 1 second, look at that. The fader dropped down to the bottom and the preset dropped as well. Why? Because someone in the room hit the button on the wall, which normally might not talk to us, but because we're polling it every second, within a second, the UCI will update to reflect the actual state in the room. That is the behavior that we want. And if it were for some reason to be disconnected, which, it could be if I were to, change the port or the IP address or something, we would see all those controls fade out. Lovely? Okay. One last thing I do want to do. Oh, Jeff, what do you got for us?
Oh, yeah. I did mine, as you might imagine, a little bit differently. So if you look at Nate's code there, you'll see that you have the set is disabled and is taking a Boolean. And in fact, that Boolean is either true or false, but it's actually tracking with the Boolean that's coming from is disabled.
Ooh, I know where you're going, and I like this. I like
connected.
This. Yes.
So we actually can get rid of the else.
Pop it here.
Yep.
Yeah.
Except you actually need to flip.
I need to flip it.
The Boolean.
Give myself a operator not.
Yeah. And we can pull the code for the disability out of the whole thing.
Yep.
And so now it just auto-magically works.
Either way, whether it's on or off, afterwards it checks to see, and it uses the Boolean of whether it's connected to change it. I like that. It's slick. And there's, like I said, it's how your brain works. Different ways of approaching it, and same end result. This one's fewer lines of code. My way is maybe might be more legible to someone who's reading it for the first time, because they can see the if and the else.
Totally. So while we're here, this, by the way, for those of you who are on the front end of your coding journey, this is very representative of exactly how it works. You make something that works, you see, yes, victory. And then you look at it and be like, but could I squeeze this a little better to make it a little more succinct, a little more clearer? And then you recognize the pattern of, oh, I've got these two Boolean lines in each of the flow controls, and it's just reverso of the states. Oh, I can just make this move. So if you didn't see it on the first time around, that's okay. That's to be expected. Because look, all of us don't see it the first time around. I wrote it exactly the way he did, and then I looked at it and I said, oh, I bet this will work. And then I did it, and it did. But I messed it up because I'm like, shoot, I need to put in a not because it turned on, it started polling, and I didn't have my buttons.
Where'd my buttons go?
Right. So, but that's writing code.
Yeah. It's noticing patterns and seeing where you can make those patterns more efficient. Yeah.
Yeah.
One last thing I want to do in here, we could have, and you could have chosen to do this as well. You could have added the connection block that says, hey, on connect, that's when you want to start it, or on disconnect, that's when you want to stop the poll. That's another way to do it. That's fine. We chose to do it within the poll event handler. That's fine too. But what else might you want to have occur when the lights connect or disconnect? I mentioned this at the top of this section. You might want to report that information up to the core manager, because if this device is not otherwise being managed, you might want information that it's connected. Or if it's an error, like it's disconnected, you want an error report so that maybe someone can come and fix it. Have it being broken in the room and no one knowing that's broken, not very useful. So a couple blocks you could use for that. If you go to your System tab, there are some at the very top called log message and log error. And this will send a log up to Core Manager for a safe message, like, hey, things are good. I would use a log message. And for something that it needs some activity, someone to look at it, I would probably use the log error. And then you can just put, some information in there. Like I would just say the lights successfully connected. And then maybe down here I would say, something is wrong with the lights, and you might even be able to concatenate in there some various bits of information that could be useful. But just wanted to show you those blocks. We haven't had a chance to show them anywhere else. So those are your log message and log error blocks, very useful for reporting. We'll talk a little bit more about other ways that we report up to Core Manager and Reflect in the next section. But that wraps up our lighting controller. Save your file. Got any last words for us?
The only thing I would consider is don't spam your logs. If you don't need the message, turn it off.
Yeah, good call. All right, take a break. We'll see you in the next section.